All right, so just to address something, in the last video, we found the broadcast IP to be 31.6.128.63. So this was actually the IPv4 address is a mistake by the professor in the exam. So this 31 should have been a 1. So that's why in my solved paper, the broadcast address that I wrote was 1.6.128.63. So it should have been the same even if I got it from the IPv4, just the IP is a mistake. Also, Zoom doesn't show any mic activity. Is my mic working?
Yep.
Okay, just glitch. Okay, so now row 2. We have an IP address, we have the first host, and we have the broadcast address. So now I'll show you a little trick that works when you have the broadcast address. +2 123 1255.
Is it recording?
Yeah.
So
So this is the broadcast ID. From now on, I'll be writing broadcast. What is it IP? Broadcast address, right? I'll be writing it as BID because BAD just means bed. So we can get the last host from the broadcast ID easily because the way this goes is it's network ID. Network ID is the first IP, and then the first host is just network ID plus 1. So the last digit of network ID, if it's 0.17, the first host will be 0.18. And then you go with the network, and then there's the last host. And after the last host, you have broadcast ID. So you can find broadcast ID, like you can find last host if broadcast ID is given by just subtracting 1 from the end. So if the final of broadcast ID is 255, the final octet in last host will be 254. So if this is the broadcast ID, then last host will be 2133.1.254. That's it. So now you have found, keep in mind, this doesn't work the other way around. You can't find the broadcast ID from last host by just adding 1 to broadcast ID because there might be routers. So now we have the last host. We now need to find the address mask. So we can do that by comparing the first host and the last host. First host is 2.133.0.1. 2.133.0.1. So you know the comparison, right? That we did last row with between first host and last host. We'll do the same thing
binary.
again. So just to practice, can you guys convert it to binary? Like for us, just convert 254 to binary.
254.
Yeah.
Okay.
254 is 7 ones and the last one is 0, right?
Yep. And
It's
it's 8 digits, right?
1111110.
So let's write the first source first. So it's 0, 0, 0, 0, 0, 0, 1, 0. And what's 133? I'll just convert it using the converter. This 1 and then 4 zeros. 1, 2, 3, 4, 1, 0, 1. Third one is just 0, so it's 0. 0s. Fourth is 1, so 0, 0, 0, 0, 0, 0, 0, 1. Okay, that is F, first host. Now last host is 2. Well, I shouldn't have wrote the whole thing again. You just need to write the ones that are not in common. So 2.133 are already identical. So you only need to write the last two octets. So I will just cross out the first two octets here from the first host. And the last host, so I'll have to write 1, 0, 0, 0, 0, 0, 0, 0, 1, and 254, which is how much?
7 ones and the last one is 0.
1, 2, 3, 4, 5, 6, 7, and a 0. So you can see that until here it's the same. It starts being different here. So the network mask will be 1, 2, 3, 4, 5, 6, 7. So it will be /7, which is a very weird mask. Wait, let me just check something.
Brother, why is it so?
Yeah. No, I don't think we're supposed to compare the first host and the last host unless we actually get it, like we are given it. So the better way to calculate the mask is, let me check flow 2.
Isn't it just
Oh
15
yeah,
plus 7?
yeah, I just
16
had
plus
a
7.
brain fart. Yeah, you're right. So it is correct.
So it's 23.
So this is 7 bits, right? 4, 5, 6, 7. But we forgot the two octets that we left out. So this is 8 into 2, 16. So this will be 16 plus 7, which
Yeah.
is 23. So the mask is /23. So yeah, so the mask will be /23. And now we have the last source, we have the mask, we have the broadcast. Now the only thing left to find is the number of addresses that's usable. And another thing we check, is this connected? No, it's not connected. So the formula will be very simple. 32 minus 23 minus 2 and no routers. So 32 minus 23 is I think 9. Yes, it's 9. 2 raised to 9 minus 2. You can just leave it here. You don't need to solve it. If you want to solve it, then I think you can do like using the law of multiplication is 2, 6 multiplied by 2, 3 minus 2. 2, 6 is 64, 2, 3 is 8 minus 2. 64 into 8 is 510 minus 2. Well, no, it's 512. 512. If you had memorized this, like, you know what I said, 2, 4, 8, 16, 32, that you would have already known 2 raised to the power 9 is 512. So this is 510, number of usable addresses. And that's it for row 2. Does anybody have any questions?
Nope.
Yep. What's up? Like, does anybody have any question? I think I heard a yep in there.
I think everyone said
Oh
no.
no, we got it.
Yeah, right then. So now we move on to row number 3. So row 3, we are given an IP address. We have given, okay, now we are given the address mask in this form. We should convert this to CIDR form. So this is the 255.224.0.0, 255.224.0.0.0. So we just convert it to binary. Can you convert 2 to 4 while I write it down? 255 is just 8 ones.
3 ones and 5 zeros.
Oh yeah, happens to be right. Alright, so we don't even need to write the last two octets. We already know that the zeros start from here. We can see that this is 8, 9, 10, 11. This is 11 ones in a row. Let me just confirm. Yeah, it is 11. So the net mask for this will be /11. Let me just confirm with my work. Yes, it's 11. Okay, so we have it 11. This will be useful for the formula. Now, what else do we need from this? We found the net mask. Well, we didn't need to find the net mask. We just needed to convert it to CIDR. First host, last host, and the broadcast address. So now for this, you will need the comparison method. We will compare the IPv4 address with the mask. So the IPv4 address is 127.0.0.1.
When is it optimal to use the comparison method, and when is it better to use the other one?
It depends on which one you're faster with. Everything should check out at the end. Like in this case, we don't have any other option. So in case of optimal, it's used in supernetting. Like there, it's optimal to take the address that's the most above. But right now, you can take any. Like here, I could have found the net mask from this first host. I could have found it from last host. I could have found it from IP address. It would have all been the same. So that's why here, you don't have anything besides it. So of course, you're gonna have to compare the IPv4. Keep in mind, this IPv4 address is just one IPv4 address from the network. It's a random address. It could even be the broadcast address. Like in row, I think it's row 6. We take the broadcast, no, yeah, row 4. We take the broadcast address as the IPv4 address. It's possible, you can do it. But yeah, for now, we'll just compare 127.0.0.1 with the netmask /11. So I convert 127 to binary.
Okay.
It's just 7 ones. So 0, 1, 2, 3, 4, 5, 6, 7. Mm, 1, 1. And then you write the mask, which is just 11 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we have zeros. Zeros until the end. You don't even need to write it when you get used to it. You just draw a line right here. So this is the network part. And this is the host part. So we need to find the first host, right? First host and last host. For that, we need to find two things. One is called the network ID, and the other is the broadcast ID, like I already said. So we already know this is /11, so I'll delete this as well. /11. All right. So here we'll find the network ID. Network ID is just we change all these to 0, like all the octets in the host part to 0. So we can see that since it's here, can we leave out the first octet?
It's the opposite for the host ID, right? So for the host ID, we turn all of them to ones, but here
Yeah.
it's to zeros.
I think you mean the broadcast ID, right?
Yeah.
Yep. So for now, first we go with the network ID, and you're right. For network ID, we change all of the host parts to 0, and for broadcast ID, we change all of these to ones. That's why usually you see a 255 or some other big number at the end of a broadcast ID. But anyway, that's just from experience. It's not a rule or anything. So network ID, first octet is untouched. So we start with the second octet. we can see that if we make everything 0, this is already 0. But since I'm teaching you guys, I'll just do it. The 3 octets will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So you can see that the network ID is first octet is 127 dot. The next 3 octets are just zeros. So dot 0, dot 0, dot 0. And in order to find the first host, all we have to do is add 1 to the network ID. So the first host can be, well, not can be, it is 127.0.0.1. And thus you have the first host. Now for the broadcast ID. Second octet. Okay, now this is more this is more work. So first you write ignore the first octet because it's unchanged. The second one, write the network part is 0, 0, 0, and the rest just ones. Okay, so you can, okay, I'll just write it because I'm teaching, but you will see that since this is all ones, what is all ones in 8-bit?
All ones as in that's 256, right?
255. You might have noticed that RGB values, they are also 8-bit. You might have noticed that RGB maximum value is 255, 255, 255. It gets you white.
Yeah.
It's the maximum value in 8-bit. So we already know this is 255. This is 255. So we just have to convert this. And this is 0, 1, 2, 3. So I'll just one more time I'll write it. So this is 2, 0 plus 2, 1 plus 2, 2 plus 0, 1, 2, 3, 4. You can use this formula. 2, 4 plus 1 minus 1. 2, 5 minus 1. 2, 5 is 32 minus 1. 31 is the broadcast ID. So the broadcast ID will be, so this first octet is 31, so it will be 127.31.255.255. This is the BID. Let me just confirm it. Yep, it is correct. So now, in order to find the last host, all we have to do is subtract -1 from the last digit. So we have L host, which is 127.31.255.254. Boom, that's it. Now I suppose there's only one thing we need. This is our tree, right? We have found the first host, we have found the last host, we have found the broadcast address. So number of usable, we check if it's connected. Yes, it is connected. So we put in the formula, it's 11, right? 32 minus 11 minus 2 minus routers because it's connected. 32 minus 11 is, I think, 21. So you don't even need to solve it. You just write 2 raised to power 21 minus 2 minus routers in the exam. And that is the answer for
How many routers are there?
What?
How many routers are there for the
This is actually a
column?
variable. You just have to write it there. It's kind of like when you open an integration, you have to write plus C, right?
Yeah.
It's like that.
Okay.
It can change. It can be anything. Routers can be 5 million or only 2. But according to the professor, you have to write it. But don't write it if it's not connected. So that would be row number 3. Are there any questions?
No.
No.
Okay, then, so we move on to row number 4. Row number 4, we'll see that the IPv4 address is not given, the mask is given, and the broadcast address is given. In this case, you can use the broadcast address as an IPv4 address in the network. Let me show you. So we have an IPv4 address of 123.175, 123.175, and a net mask of /28. So 28 ones in a row. So since we have these, and we need to find the first host and the last host. You can find the last host instantly by doing by just subtracting 1 from the broadcast address. So I'll do that at the end. First, we'll find the first host. So what do you need to find the first host? We need the network ID, which is the IP right before the first host. So in order to find that, we'll just compare these. We compare 175 to binary. Yeah. So I'll write the IP. It's 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, and 3,
1
0.
1.
Yep. 1 0 1 0 1 1 1 1. So 1 0 1 0 1 1 1 1. And then I compare it with the mask, which is 28 ones. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28. So this is a network, this is host. So the weird thing is, actually, since we use the broadcast IP as the IP, you can see that the last 4 bits are already 1. That's the magic of computers. Is like when you see it for the first time, it's pretty interesting. But yeah, it's already ones. So all we have to do is make these ones into zeros. And as you can see, only the final octet is changed. So all we have to do is convert 1 0 1 0 0 0 0 0 to binary, which will be 0 1 2 3 4 5 6 7. So 2 raised to power 7 plus 2 raised to power 5. 2 7 is 128, 2 5 is 32. So with this 20 30 is 50, 160. Yeah, it's 160. So this is row 4, right? Let me just confirm with my work.
Yep, this is row 4.
Yeah, network ID is 160. So 160 is the final octet. So just to confirm, we'll write network ID. First octet is 1.2.3. Last octet is 160. So now we'll have to find the final octet. Well, not the final octet, the last host. We already have broadcast, right? Subtract 1, you have the last host. Or this is network ID.
159.
First host will be just plus 1. So 1, 2, 3, 161. And broadcast ID, broadcast IP is 1, 2, 3, 175. Last host will be, any guesses?
174.
Yep, 3, 174. So since we are done with this, everything except the number of addresses, you always know the formula. You just have to not put any routers. You have the CIDR, and that's it. Any questions for row 4?
Nope.
No.
Okay, let me check the amount of time left for this one. Well, I don't have Zoom, so I'm gonna restart the meeting anyway, because I know they're gonna stop it at the most inconvenient time. So I'll end this meeting and it will take some time for the recording to convert, and then I'll post the new link. Until then, just take a break, drink some water, take a shit, whatever. See you guys in a bit.
Okay.
Okay.